Hello everyone. The topic of our group is functional food based on Mesona Chinensis Benth and the study of immunomodulatory activity of its polysaccharide component. This is the outline. Part is the introduction of Mesona Chinensis Benth. Mesona Chinensis Benth, a plant of the family Liabilities, is a well-known medicine and food plant in Asia. According to the Chinese Medicine Plant and Illustrated book, Mesona Chinensis Benth is a curing and search-quenching agent. Documentation of the whole herb is used to treat diabetes. Polysaccharides are the main active substances in Mesona Chinensis Benth, which have immunomodulatory, antioxidant, antitumorous, and hypoglycemic effects. Next is the exchange polysaccharide from Mesona Chinensis Benth. We use ultrasound exchange methods. The specific methods are as follows. The dry Mesona Chinensis Benth powder was weighed and heated in 1.5% sodium carbonate solution, and the ultrasound was inserted into the solution of the reaction version to extract the Mesona Chinensis Benth and polysaccharide by using ultrasound at a certain frequency on the herbal tissues. The ultrasound power was 400 W, and the extraction was carried out for 30 minutes. The extract was filled up, and the impurity was removed with ultrasound and finally frozen dry.
Polysaccharide analysis includes polysaccharide composition is diverse, structure is complex, and the molecular weight is large, so it is usually analyzed from the following four aspects. 1. Determination of sugar content. 2. Molecular weight determination. 3. Component analysis. 4. Structural identification. Based on HPLC UV detection technology, the pre-column derivatization and HPLC analysis of polysaccharide hydroxide in Mesona Chinensis was established by using the derivatization of 1-phenyl-3-methyl-5-pyrazolone. The derivatization conditions of monosaccharide and HPLC gradient illusion analysis process were optimized. As a result, 8 kinds of monosaccharide, such as ribose, ribose, and arabinose, were identified. Applied to the analysis of 18 kinds of Mesona Chinensis monosaccharides produced by the degradation of Mesona Chinensis polysaccharide was only galactonic acid, glucose, and galactose, and the component contents are 2.5 to 20.48, 2.97 to 38.52, 2.72 to 89.32, respectively.
Next, I will introduce the effect of sensitization. We know food allergy is a type 1 allergic reaction mediated by IgE. IgE basophils are an important component of the allergic responses in type 1 allergic reactions. In order to assess the effect of Mesona Chinensis Benth on food allergy, such as peanut allergy, firstly, we can perform an immunoblood analysis by transforming a mixture of peanut proteins and Mesona Chinensis Benth onto NC membranes and determine the potential sensitization by observing the color development. Secondly, we can continue to estimate the IgE binding capacity by indirect competitive enzyme immunoassay. Finally, using the KOH1-2 cells model further examine the effect of Mesona Chinensis Benth. And Biosensing mice are easily to breed, and their immune system is similar to that of humans, and are widely used in food allergy studies. To further investigate the effect of Mesona Chinensis Benth on the sensitization of individual organisms, we assess the sensitization use of Biosensing mouse model with a common immunization program divided into two phases, sensitization and elicitation. As shown in the figure on the right, immunoglobulins are important parameters of allergy, and it is crucial to detect IgE, IgG, IgG1, IgG2A levels in mouse serum. MMCP1 level increase enhances the permeability of intentional infectious cells. In addition, in mouse model, changes in cytokine production by slapenic phagocytes are often used to assess change in sensitization potential of proteins. We examined the production of Th2 type and Th1 type cytokines.
Next part, we're planning to use a new optical biosensing technique for biochemical monitoring. It can provide fast and robust ways to detect or target objects from a variety of samples. This new biosensing technique are based on nanophotonic Metasurface, which is a two-dimensional artificial device and composed of many sub-lens resonators, as we can see from the left picture. The main purpose of Metasurface is enhance the signal for detection, so it always combined and together using with the traditional sensing technique. These Metasurface-based biosensing techniques have various types. One big category is refractometric biosensing. They are based on strong Mi-type resonance in dielectric metasurfaces, giving rise to pronounced light matter interaction with the analytes in the vicinity of the resonators. By carefully tailoring the metasurface design, the resonance can be sensitive and responsive to the optical properties of the surrounding media. Analyte widening on the resonators creates local changes in the refractive index, which can be detected and quantified by tracking the resonance wavelengths or the induced changes in the transmission and reflection spectrum. Usually, those nanopillars can easily lead to refractive index changing and further increase detection sensitivity. An alternative method to refractometric detection for biomolecule sensing is vibrational spectroscopy, which allows not only to detect surface-bound molecules, but also provides chemically specific information about each analyte. Spectroscopy techniques like Raman and infrared absorption spectroscopies enable label-free sensing and monitoring of chemical reactions and interaction kinetics between various analytes. Raman spectroscopy probes molecular vibrations via inelastic scattering mechanism of the photons, whereas infrared spectroscopy accesses the chemical information via light absorption measurements. Using Metasurface can both strongly enhance lead-better interaction and increase molecule cross-section for scattering, thus increasing detection capability of spectroscopies. In conclusion, this Metasurface-based biosensing technique has advantages like high sensitivity, high responsive, well used for low concentration analyte, and will become more popular in the future. Finally, we'd like to introduce kind of food made from Mesona. Usually people call this grass jelly. It smells fragrant with a slightly smoky undertone and has a dark brown looking, sometimes perceived to be black. Besides sweet taste, you will also have a herbal taste with a hint of mint. We list a procedure for how to cooking it in this slide. Usually, it can also be eaten with fruit and bring many health benefits, such as boosting immunity as mentioned earlier. That's all for today's presentation, and thanks for listening.